Hello and welcome to PCMINR.com, and you're watching this video on important concepts of current electricity by Sonal Gupta. And I want to tell you students, push yourself because no one else is going to do it for you. And the topic for this video is resistors in series. So let's start with an application, like where do you see resistors in series in your daily life? So when you enter your drawing room and you turn on this beautiful chandelier, what are you going to do? You just turn on one switch and all the lights, they turn on. That is possible because of all of these are connected in series with each other with one switch. So all these lamps, they are connected. Like when one switch can turn on, right, if there is just one switch, like sometimes it happens otherwise also in your home, like with one switch you can turn on the fan and the light both. So that is the case where your resistors are connected in series. Your combination of that resistors, I would say here, would be your lamp and the fan. That's just a load what we are running. So they will be connected in series with one switch. So let's learn about the series combination some more, like how the physics of series combination is involved. So when you look at this circuit diagram, we have R1, R2 and R3. There are three resistors connected in series because it's like end to end. You see, this starts from here, ends here, and the next one, the beginning of the next wire is connected to the end of the first wire, and then again the next one. So this clearly indicates a series combination, first then second then third. And here the end terminal of the first is going to be connected to the initial terminal of the next. Now here one thing that is very important, to note down is that your current I is going to be same throughout. So you have a current I flowing through every resistor, right? So a same current, because there's no other path to follow, so the current cannot be divided. So you have a current I flowing through this entire circuit through all the resistors. So we would first mark that the current flowing through the entire circuit is I. But the potential difference is going to be different because they are all connected, but there will be a drop across the first, then across the second, then across the third, because potential that you're applying here, this V is the potential difference. It's just like you can imagine energy loss happening at each stage. So when your potential difference applied is V, so we write here potential difference is V. It is going to be, the first resistor is R1. Your potential drop happening here would be V1. Then we move to the next one. The potential drop happening here would be V2. And then we move to the next one. The potential drop happening would be V3. It's because across the first resistor, whatever is its value, based on that resistance, some potential will be dropped. It will decrease and then go to the next part. Then there will be again a loss, and then the remaining would be transferred to the last part. So when we are talking of resistors in series, the applied potential difference is V, but V1, V2 and V3, these are the potential differences across the resistors R1, R2 and R3. But it's important you remember that I is same, as there is just one path to follow throughout. So I is same across all the resistors, right? Now when I is same across all the resistors and we apply that Ohm's law equation, V is equal to IR, right? So we'll write here, by Ohm's law, we know that V is equal to IR. And also V is equal to the sum of all these three, because whatever is the sum of these three potentials, that's V1, V2, V3, that's going to give you the total potential difference applied. So V is equal to V1 plus V2 plus V3. Now V is IR, but your V1, V2, V3 would be IR1 plus IR2 plus IR3. That means the current flowing through each of them is same, but R1, R2, R3 are different, and so I throughout would cancel out. It's common, and hence we get the net resistance, or we also call it as equivalent resistance of a series combination, is going to be the sum of the resistances that are connected. So if there are 3 resistors connected here, we can see that there is R1, R2, R3, they're just getting summed up. Hence, we would say the net resistance or the equivalent resistance, therefore equivalent resistance increases. So if you want to increase the resistance of a circuit, like we want to control the amount of current to be flowing, we want a lesser amount of current to flow through a circuit, we would connect all of them in series, and that would increase the overall resistance of the circuit. But one problem is there with this circuit, that if like we used to have some lights, the fancy lights which we use for our for lighting of the houses, like in lighting of the houses in Christmas time or Diwali time and during the festivals, there we used to have all the bulbs. Early times it used to be connected in series. So if one bulb blows off, this is not working, the path gets obstructed and the rest all also stop working. So none of the bulb would glow, and then it's very difficult to find out which bulb is at fault. So series combination had this problem. And another thing is why we don't generally have the series combination in the houses for all the lights, because it will be like only for the chandelier it works well. But if you have, just imagine if you have a single switch which is turning on the fan and the light and the AC and everything in your room, and if any one goes bad, like anything is damaged, all of them would stop working. So we want an independent working of all the appliances in a house. That's why we don't prefer series combination. So this would be used only if we want to increase the resistance in a circuit, or where we actually want something to light up together, like in case of a chandelier. So I hope this combination of resistors in series, how it works, where do we have it in our life, where it works for us, and how the resistance gets impacted when you connect them in series is clear to you. If you find this video helpful, please like us, subscribe us, and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.